Well, good afternoon, good evening, or good morning, depending on where you are in this world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, the moderator for today's event, and I welcome you. Today we have a really fascinating webinar that's very topical also. But before we get started, I would like to go over a couple housekeeping items. First of all, today's webinar is being recorded. So if you miss any or all of today's webinar, please know that you'll be able to listen to it on demand after the event. We'll be sending an email post-event with a link to the webinar on demand. It will also be located on the DevOps.com website, so you can also find it there if you need to. And we will be taking questions from the audience following the presentation. So if you have a question at any time, just use the control panel there, so type in your question, and then we'll take a few minutes and go through the audience questions. Okay, with that, I would like to dive right on into today's webinar, which is a discussion of automated infrastructure security with a practical example. Our speaker today is W. Jenks Gibbons, who's Senior Solutions Architect, easy for me to say, at Cloud Passage. Welcome, Jenks. Thanks for joining me today.
Absolutely. Thanks for having me.
Well, I'm going to go ahead and just turn it right over to you and let you do your thing.
Cool. Okay. Sounds good. Hi, everybody. My name is Jenks, as we just heard. And, boy, that sounds just... The introduction and the title of the topic sounds a little dull, but I think this is going to be a lot of fun.
Yeah, I was like, that sounds almost like a term paper or something. But
I know, right? So I think this will be a lot of fun. We're going to talk about automated compliance, 24/7 compliance, and go through sort of an example use case study, and then go through a practical example. And I think that you guys will find this interesting. Just tell you a little bit about myself. I've been in the computer security space for, I guess, a little over 11 years, doing stuff from encryption to infrastructure security, and I've been sort of in the DevOps space for a few years now, and looking at how you can automate infrastructure security the same way that you automate code deployments, and using infrastructure as code and whatnot. So let's jump on in. I'm sure that since this is sponsored by DevOps.com, I'm sure that everybody on the call is probably familiar with DevOps. If you're not familiar with DevOps, the Phoenix Project is a good book. It's a fun story because these environments actually do exist, and the problem that I have with that book is that it's like 99% problem, and sort of the solution at the end is sort of like, ooh, magic. And so if you get into the DevOps handbook, which goes a little bit more low level, that goes more into the solution and the introduction of CI/CD and some case studies with Nordstrom and Etsy and stuff. So what we're going to talk about today is not DevOps, but bringing security into the DevOps process. So we're going to sort of start out and talk about, is security a roadblock for continuous delivery? I would argue that a lot of security professionals would agree that it is. A lot of developers would agree that it is. So let's take a little bit more of a look at this. So if you're looking at traditional security tools, a lot of times where the security gate's going to come in is at the deploy phase. So you have your pipeline, you've done your CI, you've run it through the different environments, you're ready to deploy, and all of a sudden, boom, everything stops and says, you know what, you have to pass these security checks before you can push. So what we're going to look at today is how we can provide developers security guardrails. So an area where they can bounce around, and if there's a problem, they get notified very quickly, it can be fixed very quickly, and we can really work to get the business units what they need ultimately so the company can be successful. So we're going to look a little bit at this Helix, and it's a continuous process that involves both people as well as automation. So we'll start out with a planning phase. So planning, looking at the types of systems that we have, looking at the types of security policies that we have, and that way we can plan out putting like functioning systems in like functioning groups, because they'll use the same types of security policies. as we go through, we're going to need to create the automation of this security. So in the example that we're going to use today, we're going to use an example that uses a small agent, and that agent was built specifically for public cloud infrastructure. So it's very small, so about 2 megs on Linux, 2 megs on Windows. But we also know that most companies are not fully in public cloud infrastructure. So most companies have some private cloud infrastructure. They also have some bare steel. So we need this agent to work anywhere. So wherever workload comes up, it comes on. It can be installed through general orchestration tools, so it can be automated. So the security just goes along for the ride. And that would be, using Chef or Puppet or Ansible or SaltStack or whatnot. Then we go into a verification stage. So generally what happens in the CI is that a developer will do a check-in, and that check-in can be for, just code for a product, a web app or whatnot, or it can be infrastructure as code. So that kicks off the build and takes the build verification through the pipeline of smoke tests, pre-prod tests, whatnot. And generally that's where things are pushed. What we're going to do today is we're going to put security into that automation process as well. So we'll do an infrastructure check before we push as well. So for example, we'll do a software vulnerability assessment to see if there are any critical CVEs on the infrastructure. We'll do a configuration security check to see if there are any configuration issues, for example, based on CIS benchmarks for the operating system or for common applications such as Cassandra, Apache Nginx, whatnot. So we'll add that in. We'll also look at some monitoring aspects for after you push, for example, for file integrity. Now these are going to be pre-production policies. As you push and you release, the policies may change. You may have firewall policies. You may take a file integrity baseline because you know that you're going to be out in the wild then, and your files may change. So and when we talk about files changing, the way that you can think about this is all based off of a golden image. So when you created this golden image, you knew that the software was good, you knew that the configuration was good, and you knew that the file integrity was good. At the time of launch of the infrastructure, you don't know that that's truly the case, and that's what we're checking. So as you do this, when you push, you can configure it and you can change it. You can take a file integrity baseline, for example. You can put out log-based intrusion detection rules for indications of compromise or whatnot. And then you'll go into a monitoring phase. So once it's pushed, you're going to want to monitor to ensure that there are no new vulnerabilities for longer-term instances. Ensure that there are no configuration problems, ensure there are no file integrity problems, and you can even hook it into automated remediation platforms. You can, for example, write your software vulnerability results into an Ansible playbook and automatically remediate. You can automatically send tickets to Jira or Snow or whatnot to automatically open tickets for critical issues, to automatically close those tickets when those have been resolved and whatnot. So we're going to look at a case study now, and Acme Incorporated. And I sort of laughed when I did this because I think that Acme, I don't know if the history is actually from the Roadrunner, but I know that it was in the Roadrunner, but I think it's actually got a longer history than that. I looked it up when I first wrote this, but I can't remember, so that'll be your homework. So we're going to look at a sample use case here. So this is a shop that currently uses DevOps, and so the development and the operations guys, they work together, and they understand the needs of the business unit. So I would argue that pretty much every company now is an IT shop. So what happens is, let's say that you're, I don't know, a comic book store or whatnot. If your IT team and your development team can't keep your point of sale system up and running, you can't sell things, and the business is ultimately going to go under. So the development and the operations need to understand what these business units are doing so they can support them, so ultimately the company can be profitable. So the development and operations teams here, they work together on their area of responsibility, independent of other teams. So one of the things that does is it gives people a sense of ownership. And when people have a sense of ownership, they generally care more about things, they're more invested in it, and they'll put more of their time into making sure that it works well. So they're using a continuous integration, continuous delivery model. They're delivering features multiple times a day. The delivery does not require external approval, but deployment requires security operations approval. So this is the current problem. So one of the things that we're working to do is we're working to deliver at the speed of the business units. So the business units need their new features to be able to keep up with the competition, to be able to be profitable. Security is blocking deployment though, however. So some examples of this is, let's say sort of the common example that was brought up originally in the Phoenix project is push 10 times a day. So if security says there's a 5-day SLA on a vulnerability scan, or security says that there's a 5-day SLA on a firewall implementation, because for example, let's say that you're in public cloud infrastructure, but it connects through a PAN back to your data center. And everything that has to be deployed has to have firewall rules to make sure that the traffic back to the data center is good, but that's a 5-day SLA. If your SLA is longer than your push time, there's a clear roadblock. So delivery is many times a day. The team's autonomous. Delivery team and deployment team are autonomous. Deployment approval, multiple teams. But in this example here, if your deployment requirements are longer than the delivery, then you just clearly hit a roadblock. So we're going to look at some of these problems. I need to get rid of this slide because I don't like it. So we're going to skip it. So here in this current example, what you have here is you basically have hours or days to be able to deploy. So you're going to go through and you're going to code and commit and push and test. And if things pass and you're ready to push that infrastructure out, then it could be hours or it could be days before you get the approvals that you need to actually push. And what's happening is that those business units are waiting for the features and you've just hit a full-on roadblock. So we're going to look a little bit here at the solution. So the solution, so one of the things that we can look at is before we said, okay, we're going to put development and we're going to put operations together, and that's how we're going to really work to get the business units what they need. So we're going to take that same concept and change DevOps to DevSecOps. So we're going to embed a security member with the development and the operations team. And what we're going to do is we're going to add security to this pipeline as well. So here's our plan. So development, operations, and security are now working together in autonomous feature teams. Now the operating system image, we talked about this a little bit earlier. They are going to work together to create a golden image for each platform. Now what a golden image is it is an image that you've created and you know that there are no software vulnerabilities. It's configured, for example, based on CIS benchmarks. The file integrity is good. It's hardened. You know that it's golden. It's ready to be used. That being said, as time passes, there are going to be software vulnerability problems. Configurations may have drifted. There's going to be problems with it. So you always want to check before you push, because the idea is that whether you're in a PCI environment, whether you're in a HIPAA environment, whether it's just an internal audit, the idea is that you want to know there's a problem now, not 3 days from now, not 3 months from now. You don't want to be sitting with a PCI auditor and explaining to them why you don't understand that there is a problem. You want to look at them and say, this is when I found the problem, this is when I fixed the problem, here's the audit trail. So what we're going to look at today is we're going to look at infrastructure security, and we're going to use some common tools, and these are just examples. There are different CI servers, there are different source code repositories, just some common tools that we're going to use. And right now we're just looking at sort of these groups. So Jenkins hosts are going to have different security requirements than a web group or a PCI group or whatnot. So the different groups are assigned different security policies. And I jumped a little bit ahead on the tools. I saw Jenkins there. So we're actually talking about groups now, so we'll get to the tools in just a little bit. So some of the security items that we're going to look at in this process are software vulnerability assessment, and these are going to be based on CVEs, Common Vulnerabilities and Exposures. configuration security monitoring, and like I said, those will be based on CI's benchmarks for the operating system and for common applications. File integrity monitoring. Microsegmentation is something that we could look at as well as far as protecting that east-west traffic for virtual machines. And log-based intrusion detection, which is indications of compromise. So seeing that somebody failed to SU 3 times, seeing that somebody tried to log in with a root key, seeing that somebody created an account, whatnot. So indication of compromise that can be sent to your SIM, for example, for alerting and correlation. So when we create, what we're going to go ahead and do is we're going to enable this automated security into the pipeline by installing this agent that we talked about earlier. So you can bake it into the image. You can use common orchestration tools such as Ansible, Chef, PowerShell, Puppet, Packer, whatnot. And some of the things that are important is ensuring that the agent works in any environment. So Netflix is one of the only large companies that I know of that's completely out of the data center. Most companies have public cloud infrastructure, private cloud infrastructure, and bare steel. And if a company says, you know, we're all in AWS, you know, and we'll never be anywhere else, well, what happens if you have an acquisition and all of a sudden you have a bunch of Azure machines? So you need to be able to work in any environment and ensure that the security works in any environment. So if it comes up anywhere, the security goes along for the ride. It needs to work at any scale. So if, for example, on a Friday afternoon at 4:30, if somebody kicks off 20,000 instances, the security needs to go along for the ride for all 20,000 just automatically. So it needs to happen on demand and needs to offer a broad range of controls. So you have a broad range of security controls all in one place, so where you can look at everything in one place. And I guess the other thing that would be that I haven't actually called out specifically in here, and I just realized that I didn't, that's very important, is APIs as differentiators. So none of this can happen without APIs. So I guess I'll call that out specifically. And I think an API can really, really, really differentiate a product and take a product that's very powerful and just turn it into a superpower with what you can do with the API, and that's what we're going to be looking at today. So in pre-production, when the workload boots, it's important to be able to tag that workload with a group. So as it comes up, if it's tagged as a web group, if it's tagged as a PCI group, automatically it'll go into the proper security group or the proper server group, not AWS security group, but server group. And the policies that are applied to that group will be applied to that automatically. And this is where we talk about security simply going along for the ride. So as we keep going, we are going to look at the CI process. So the security verification that we're looking at is going to be built into the CI/CD pipeline. So during CI, what's generally going to happen is you do your code analysis, static code analysis, do your unit tests, your smoke tests, your functional tests, you know, ensuring that the things that are ready for the build to be pushed and deployed. So as we talked about, we are going to add some security tests to this as well. Software vulnerability scan, a configuration scan. Now, successes and failures are going to be based on critical failures. So for example, let's say if you're in a PCI environment, anything with a CVE score of 4 or higher is going to be a failure. So success and failures will be based on this, and it'll kill the job. One thing that I do in this example is I create an audit trail. So I check all my results into Git. So I've got successes in there, and I have failures in there. And this allows me to show the auditor, this failed at this time, I remediated, I checked stuff back in, here's the success, and you can see the proof in the audit trail. So as I mentioned earlier, so on fail, and this is just a sample flow. So like I was talking with somebody last week, and one of the things that they said to me is we can't have a security job fail a build job. And in my flow, I do fail the build job. But let's say that you have a requirement. This is just an example flow. So one of the things that you could do if you didn't want to kill a build job and you needed to push, it's really understanding your risk profile and understanding what you're willing to accept. So one of the things that one of the things that you can do, for instance, is if you can't kill your build job, you take those critical vulnerabilities, you open up tickets automatically in a ticketing system so you can remediate them and you can fix your golden image and you go from there. So it's really, these are just examples and there are different ways that you can do things. So what I do here is I fail the build job and I kill the instance, I fix the issues, and then I check in the infrastructure as code to kick off a CI job. And I really work to shorten the feedback loop. So this idea of failing fast, letting people know exactly what's going on so we can fix it fast, it's sort of all built off of that original Toyota model. So what I do for my feedback loop is generally, we'll get into this a little bit more later, but I use Slack to automatically create messages for failures, for build starts, so the teams know exactly what's happening very fast and we can fix stuff fast and we can move on. So on pass, I go ahead and deploy. I take FIM baseline and I move from production to pre-production to a production workload group, and the security policies just go along. So for example, I'll have a file integrity check in the production security server group. So the monitoring aspect is, we talked about this a little bit earlier, is simply checking things for things that are currently running. So a lot of people have instances that are up, for just a couple hours, for a couple minutes. Some instances are up for a lot longer, and so we really want to monitor. And the other thing that you really need to understand is being able to do these types of checks and monitors, on demand is important. So if you're just looking at PCI, checks, once a quarter, and you're just doing your scans once a quarter, how do you account for workloads that were only up for 20 minutes? So you need to account for these ephemeral instances as well. So what we do is we'll just do scanning for software vulnerabilities, same types of scans we talked about earlier. We can alert and send things to Slack, to Jira, to ServiceNow to automatically let people know what's going on so we can shorten that feedback loop and we can fix things and we can move on. And what we've really done here is I have a large financial customer that I was talking to a while back, and one of the things that they said is, we've been able to take this from days down to minutes. He said, I get a Slack message, from the security guy or from the development guys, and they say, hey, I see this security problem. It failed my build. What's going on? They take a look at it, say, oh, there's a critical, remotely, exploitable kernel vulnerability. They patch, they redeploy, and boom, the guys are off and running in 7 minutes, and you've got an audit trail as well. So the change that you're making here, and every time I use this slide, so I'm going to remind myself to go fix this slide right after this because there's a problem with it that I don't like. So the thing that I think that needs to happen here that just needs to change is the testing should happen before the security scan, because if your tests fail, you're going to kill the build anyway, and you're not going to push the infrastructure. So what I would do is test first. If your tests pass, then go ahead and scan. Then you're creating your baseline, you're pushing things out, and you're monitoring. So what you've done is these things that generally took, days to happen, now you've automated them, and it's happening within the build process. You've got these guardrails up for the developers, and really what the ultimate thing is that you're getting the features out there that the business units need to help the company succeed, because ultimately it's about being successful and profitable and stable, and the IT department owes it to the rest of the business units to help with that. So talking about that, let's look at a practical example. And like I said, these are just some example tools that I like to use. You can use different source code repos. You can use different CI servers, whatnot. Jenkins is great. Another one that I really like actually is Travis, which I find is just very easy to use. But there's a bunch of different products out there that are really nice. We're going to talk about Slack. We're going to talk about Chef. So what we have here is this is a developer, and the developer is going to make a change to his code in a web app or whatnot, or to the infrastructure. So in the infrastructure would be making a change to that golden image. And what they're going to do is when they're ready, they're going to go ahead and check it in to Git, which is a source code repository. And what that has is it has a webhook that hooks into Jenkins to the CI. And it says, okay, there's been a change. We need to do a build job. So Jenkins is going to kick off a job based on that webhook. And like I said, it could be a code change or it can be an infrastructure change. And what Jenkins is going to do is it goes out and it's going to kick off an instance of that golden image. And I do this using Test Kitchen, so Chef Test Kitchen, EC2 Test Kitchen. Then I use Chef to install the agent that we talked about earlier. It goes through, it builds, in my example, it builds an open source pet database, veterinarian database. It builds it with Maven. Then it runs some tests on it. And if those tests pass, then it goes ahead and runs the security checks. So I get notifications for shortened feedback loops to Slack. So I see that there's a user that kicked off a build. So I know that there's a build going on. We talked a little bit earlier about this. So the API that I use is a Python SDK. It's just a wrapper around a REST API. And I find just personally that the SDK is a lot nicer. It really decreases sort of Snowflake programs and really provides the ability to have reusability in there. So all I do is I do two things. I have a workload security analysis program and a deployment program. And the workload security analysis does two things. Checks software vulnerabilities, checks configuration like we talked about earlier. If those pass, it kicks off the deployment script. If they don't pass, it fails the build job and it writes a report and checks it into Git. If it does pass, it runs the deployment script, which moves it into a production server group with production security policies. It takes a file integrity baseline, and then we move it out to start monitoring. So as I mentioned, if the build succeeds or fails, I create an audit report and I check it into Git. So here what we see is this example here. There are 3 critical findings, and you can see we had the exact time when this was found, and you can see the top finding, which is a problem with OpenSSH. And so we know what the problem is, and we know what we need to fix now. So we go through and we look at our golden image, and we go ahead and update the packages that are critical. And at this point, we're going to go ahead and create a new golden image. So we go out and this is an example on AWS. So I go ahead and create a new image with the fixes in there. I put the new AMI ID in there, and I check that into Git. And what that does is it kicks off a build. So because I've checked in my infrastructure as code. So I go through, and we got the exact timestamp. We see that there are no critical finding counts. This is exactly what I could show an auditor. These are the compensating controls that I have, and this is how I'm implementing them. And that is the last slide. So what we've looked at here is it's really the same as any CI/CD pipeline, but what we've done is we've taken and we've plugged security in there for continual 24/7 security compliance and automated compliance. And we've looked at a real-world example. New CVEs are coming out every day, and it's an example of a way that you can protect your infrastructure and protect your company and really work to get the business units at your company the features that they need so we can all be successful. And anyway, I hope that you guys enjoyed this. I think it's kind of a fun topic. I think it's a lot more fun than it sounds like when you hear the title. So, but anyway, hope you guys enjoyed it, and that's all I got.
Okay, great. Yeah, I think some people think security and they're like, oh, no, I really don't want to have to deal with it. But yeah, I mean, I guess you can never say security is easy, but you made it look much easier than it actually is, probably. So
well, automation can be your friend.
Yeah, there you go. All right, great. Well, we do have a couple questions that we can ask you during the Q&A period coming up now, but I do want to remind the audience that if you do have a question for Jenks about any part of his presentation or just about security in general, feel free to use the control panel, put your question in, and we'll take a look at it. And so here's our first question. What if you need to test in different environments, like say public, private cloud, infrastructure? You know, what do you do in that situation?
Absolutely. So that's something that we touched on a little bit earlier briefly, and let's talk about it a little bit more, because I think it's a very important question. So most companies that I see nowadays are in multiple different environments. You've got a lot of startups that may only be in AWS, and they may say that we'll never be in anything other than AWS until they have an acquisition, and they've got a bunch of bare steel computers, they have a bunch of Google computers, a bunch of Azure machines, virtual machines. And what's really important, I think there's some things to consider that are important when you're looking at security tools. And I think one of them is to ensure that they work in any environment. And that means that they work in any public cloud infrastructure, whether it's Google Compute, whether it's Oracle Cloud, whatnot. It works on bare steel, and it also works in private cloud infrastructure. So it works across any of those environments. Because the main thing that you want to do is you want a security tool where you can do everything in one place, as opposed to having tons of different point solutions. All
right, great. Next question is from Pavan, who asks, what about false positives of having security tools in CI/CD pipeline?
So I think that a lot of it really depends on the security products that you're using. So I know that a lot of for example, the software vulnerability items that we have. So we've really worked to decrease the false positives with the software vulnerabilities by using multiple different feeds, by including Elast data in there, and that's sort of a product item of the security vendor that you're using. And I think that, you know, false positives do exist, and one of the things that I really think that you can build into this is by having a channel for shortened feedback loops. You can look at things quickly and determine if it is a false positive. So for example, like there's a couple different ways. One of the most common things that you see are kernel vulnerabilities. And so a lot of times what happens is, depending on the system, a lot of systems will have maybe the last 2 or 3 kernels in there. They're not running, but they are vulnerable. And if you detect those packages and you look at those packages, you may see that there's critical vulnerabilities in there. Technically, yes, there are, but it's a non-running kernel. So you can have different things in your security systems where if the kernel's not running, you know, it's suppressed, and so those CVEs aren't seen, exceptions and things such as that. So I think there's 2 different ways to look at that. There's a product item of false positives within a security product, as well as looking at your different policies and how you define those within your pipeline.
Okay, great. Next question from Sridhara. He's asking, how many instances of Jenkins is suggested?
That's actually a good question, and I'm not going to say that I'm a Jenkins expert. I understand Jenkins as far as how it works in the CI process. The way that Jenkins generally works is you've got a master and then you have slaves that are going to run build jobs. So really the way that you set up your CI pipeline is going to be based on how many build jobs that you have. And what I would recommend is, you know, going in and, you know, looking at the requirements for Jenkins and how many build jobs you need, and then you can determine how many slaves you need for your environment. So, I would imagine that your actual infrastructure team could help you with that probably better than I can, but that's the general model for how things work.
Okay, great. Okay, next question is kind of a long one, so bear with me here. Eswar is asking, how about security checks for managed services on the cloud related to access to tables, storage, etc.? What stage would you build them, and how do you separate them based on the environment test versus production?
That is a long one. Let's see.
Yeah.
So there's a couple. I'm going to do my best to answer this. I think I heard a couple things in there. So managed services. So there's a couple different ways. So first of all, you have your idea of CASBs, which CASBs are gonna protect sort of managed services in the background that are hosted in the cloud, which is something that would be separate from here. Other managed services where you don't have control over what they're doing, that would be managed more on the managed services side, like, for example, a managed service from VMware, where they're using their security tools, and then they would be responsible for doing that. And what you would generally look at is, looking at different security compliance reports to see how they're doing things. I think it's a little bit of a separate topic, but you'd look at their SOC 2 report or whatnot. Now, if you're looking at actual protection of data on a machine, you can do different checks to confirm, for example, that any traffic that's going in and out is encrypted based on port configurations, ensuring that, if a user opens a file, you're notified on that. If its files change, you're notified on that. And these things can all be done in different environments. So as you're looking at, I think that really what you're looking at is, in a CI pipeline, generally what you're going to have is you're going to have different environments that go through for code. So you'll have your initial smoke tests on the product, then you may move to a QA environment, then maybe a pre-production environment where you've actually got your third-party services hooked in. And I think that that's actually more related to the code development, which would be separate from the infrastructure security. And so what I would say is that generally what you want to do is just right at the stage before you're going to push, check your infrastructure security to ensure that your infrastructure is good. But it really just sort of depends on the flow of the people in question. So I hope that answered your question. But if you have any further questions that I did not answer, because I know that we aren't having a dialogue here, my email's up on the screen, so please feel free to email me.
Great. Okay. Great. Plenty of time for more questions, guys. So if you have a question for Jenks, just use that control panel, put your question in. We have another one here. Can you explain the concept of providing guardrails for developers?
Absolutely, absolutely. And I think this is an important one. So one of the things that we touched on this earlier a little briefly, and one of the things that sort of happened with DevOps is that things are moving very, very, very fast. So lots of changes. A lot of the problems that we see is that when security does block things, what happens is that people go behind security's back, for example, by using AWS without permission. And a lot of times people will say, oh no, we don't use AWS at all here. I know for a fact that we don't use it. And what I say is, you very well may be using it. And the way that you can check to see if you're using it is talk to accounting. Because what will happen a lot of times is people will say, no, we don't use AWS at all, but man, this group buys a lot of books. And what happens is that people go out and they will use AWS without permission, and then they'll expense it. And one of the things about guardrails is what we want to be able to do is we want to be able to transparently put security into a process so the developers don't necessarily know that it's there, but what we've done is we've given them this area where they can do whatever they want. But there are controls there. So compensating controls. And the way that we implement those is by running these checks in the CI/CD process. And what this does is it says, hey, you installed this package that wasn't on the golden image, and it's got a critical vulnerability. Or your infrastructure is out of date. There's a critical kernel vulnerability. Or you changed the configuration of this, and port 80 is now open, on the web server, which is a PCI violation or whatnot. So what we've done is we've taken these, we've given them an allowable space to work in, the developers, so they can move fast. However, we are checking to ensure that the infrastructure is in compliance. And if there is a problem, a very, very quick feedback loop so we can have a conversation and fix the things that we need to very quickly. So that's sort of the idea of guardrails.
Okay, great. Have another question here in the and this is another long one, so again,
okay.
There. All right, in the presentation, the pipeline shows SVA, CSM, and FISM are separate entities or tasks. Since SVA tools such as Nessus compliance policy does your pipeline use the Nessus compliance feature or run separately the CIS-CAT tool from CIS benchmark? If it is separate, why? Hope you understand that.
Yeah,
okay,
no, it's
good.
straightforward question.
Right, awesome.
So no, we do not use Nessus. So Nessus is, at least in this example, we're not using Nessus. So Nessus is for, one of the things that Nessus does that is not included in this example is for an external network scan for PCI compliance. And what we're doing here is we're doing workload-based scanning. So this ensures, so there's a couple different things for PCI. So yes, you do need your quarterly scan for the external network scan to ensure PCI compliance. But the other thing that you need to be able to do is also on-demand scans for vulnerabilities on workloads. So what we're doing here is we're using a tool that does a workload-based scan, and that way we can scan to ensure that it's not just happening once a month, but we're ensuring that if an instance is up for, 20 minutes, or if it's up for 2 hours, we're ensuring that we have that scan data as well, so we can show that for PCI compliance. So that is going to be separate from the CIS benchmarks. So the CIS benchmarks are going to be for configuration security, for example, or for file integrity. And what those do is there's in the security product that's used in this example, writing security templates for CIS benchmarks is quite daunting. So there's, I think for example, for Amazon Linux, for the CIS benchmarks for the core operating system, there's like 222 checks. So what this does is it allows people to get up and running to compare their instances with the CIS benchmarks very, very quickly. And that would be for configuration security monitoring and file integrity monitoring. And then the software vulnerability data that we use is based on NIST.
Okay.
So hopefully that answers the question.
Yeah, I think it probably does, yeah. So, but if not, send
like I said, my email's up, so please feel free to email me.
Great.
So, but that's a pretty straightforward question, yeah.
Okay, awesome. Okay, next question. Can you discuss the monitoring aspect as well?
Right, exactly. So I didn't spend as much time on that because that's, well, it's not separate from the pipeline. So it's, what I have is, for example, I've got a build job, but I also have a monitoring job. So what happens is once infrastructure is out there, you could sort of think of it when it's pushed, it's a golden image, but it's the same problem. After it's been out there for a little while, it has, there are new CVEs that have come out. If it's not immutable infrastructure, then somebody could have gone out and changed the configuration. Something in the file integrity could have changed. So it's important also I have a job that Jenkins runs that monitors the infrastructure as well, and it'll alert if there are any new software vulnerabilities, any configuration changes, and that can be hooked into, again, sort of keeping with this idea of automation, it can be hooked into remediation software. For example, you can hook it into Puppet, for example, to remediate software vulnerabilities. You can hook it into Jira or ServiceNow to automatically open a ticket if there's a critical vulnerability, to automatically close that ticket when it's been remediated, which just creates an additional audit trail. So I think the monitoring aspect is important as well. And I think one of the things that's really important to keep in mind is, especially with public cloud infrastructure, these instances have become very ephemeral. So what's happening is, I kick off a movie at home, to watch a show on Netflix, and an instance is spun up. I hit stop and the instance is spun down. Well, you have to be able to talk about your infrastructure that comes up and down as well, not just quarterly scans and then not worry about the rest of the infrastructure. So it's sort of the idea of monitoring and understanding what's going on with your infrastructure at all times.
Okay, great. Guys, we still have time for more questions. If you have anything for Jenks, please go ahead and use the control panel, get your question in. We have like 1 or 2 questions left here, so we'll go back into them. What are the tools in the pipeline you mentioned again?
Yep, absolutely. So we've got, so first of all, we've got a source code repository, and the one that I talked about was Git, which is a common source code repository. And what that allows people to do is it allows people to check source code into the repository and version it, and it allows you to hook into a CI system. So one of the systems that I talked about earlier was Jenkins, which is a CI system. And what Jenkins does is it kicks off these ideas of builds. And what the build does is it launches the infrastructure, it builds the software, it tests the software, it tests the infrastructure. At that point, we also talked about Slack a little bit, which is a common messaging tool, which hooks into a notification from Jenkins to let people know when builds failed, when builds succeeded. We talked about audit reports into Git. Some other things that we can touch on that are interesting as well is that the CIS benchmarks note that it's important to monitor and secure your workload, but it's also important to monitor and secure your containers, for example. So another tool that you could think of here is having, and this process works as well in this example and these security tools that I talked about here, but having something to monitor both the host and the images, for example, on a Docker registry, for example, or on an Amazon ECR repository. So being able to monitor the vulnerabilities and check for the vulnerabilities in those images, as well as if there are any containers that have been launched from those images that have vulnerable packages inside them. So those are some of the common tools. But if you search up, for example, like Docker or CI/CD, there's some, or just CI/CD, you can see these pipelines and the common tools that are used in them.
All right, great. Well, that wraps up the questions that we have gotten in. So I do thank the audience for submitting questions. And Jenks, you made security fascinating. It was a great presentation. I really enjoyed it, and I was able to understand most of it too. So that's always a big bonus for me. So
excellent. Well, it was a lot of fun. I appreciate you having me.
Great. Well, just a reminder that today's webinar has been recorded. So if you missed any or all of today's webinar, you'll be receiving an email shortly that has a link to the webinar on demand, as well as a link to the slides. So any questions about today's webinar, you see Jenk's email right there on the screen. So I'm sure he would love it if you reached out and said hello. But you can check devops.com also for a copy of today's webinar on demand, and then also check out the list of webinars that we have coming up. We've got a ton of them, so I'm sure there'll be at least one or two that pique your interest. Jenks, thank you so much for giving us such a great presentation. I really do appreciate it.
Absolutely. Thanks for having me. I appreciate it.
Great. Well, this is Charlene O'Hanlon, and I'm the moderator for today's event, and I'm signing off. Have a great day, everybody.